Hello friends, welcome to my channel Phone Repair Tips. Today I have in my hand iPhone 14 Pro Max motherboard. After heavy drop, there is a slightly crack on the corner of motherboard and so many ripped pads on the upper layer. The phone comes to me like this after drop, no touch, but is turning on with very high booting. I hope you can see the little crack on the corner. This board was like dropped from second floor and then run over by a car, but still survived. Now customer want to fix this phone, so let's see under the microscope. So as you can see under the microscope, now this part of the board is cracked and from there is the line going 5 volt for the touch line. That's our phone doesn't have touch screen. It's turning on but with very high booting. So we will fix this motherboard uh, by swapping the CPU, memory chip, EEPROM and Wi-Fi IC to new board we prepared. So let's get started. First we will start with cleaning the side glue on the CPU. I hope we will be. This is the new 14 Pro Max CNC motherboard that I prepared for transfer the chips. We will transfer the chips on this new board. I'm testing the booting of new board. It should be between 0.010 to 0.030 milliamperes. So as you see, we have 0.019 milliamps. That booting is absolutely fine. So the motherboard is perfect for and ready for swapping. Let's get started. I'm starting to clean the side glue of the CPU. I'm using the Exxon H310 hot air station. My temperature is set to 280 degrees and the airflow set to 30 only. Just make sure to clean the glue from every corner nicely. Don't left little bit glue anywhere. So That can be a problem when lifting the CPU. Which side you leave the glue, even a little bit, it can put pressure on the CPU pads and you can lose the pads from that side. So be careful when you cleaning the glue. Make sure you clean the glue nicely and very well. On this old motherboard, I don't have to save any side components like a resistor or capacitor or anything because this board I'm going to swap. I'm not going to do the CPU on the same motherboard. So for me, even I lose some components on the sides doesn't matter because I don't have to use the same board for CPU. Only I have to be careful if I'm doing the revolve on the same motherboard. But in my case, I just have to transplant to new motherboard. So if even I lose some components, I never mind. So I don't have to be careful about side components. I just have to be careful about one resistor that called R2405 maybe if I'm correct. Sorry for my mistake if I will be wrong because the motherboard I have prepared is iPhone 14 Pro. The one I am going to swap is iPhone 14 Pro Max. So I have to transplant that resistor to that new motherboard from the old board to make it 14 Pro Max. So as my glue is cleaned nicely, now I'm going to remove the CPU. I'm using the YCS R1 hot air gun. My temperature is set to 400 degrees. I'm not using any nozzle. It's just like you can call open nozzle. That's my preferred mass method to remove CPU. The airflow is set to 130. So as you can see, I removed the CPU successfully. It just takes me about 30 to 40 seconds maximum. So let's check how our CPU looks. Yeah, from the first view, CPU seems very nice, very good. No damage pads, only a little bit glue on the CPU. That's okay. We can clean it. So everything looks good. Now we can proceed to next step, removing that NAND chip and that Wi-Fi IC. Same things we will use like the same temperature to change, clean the side glue with the Exxon hot air gun. I'm using 280 degrees and 30 air. Then I will remove it with the other gun because Exxon gun is like I call straight air and fast heat. So it's better to clean the glue with this gun and the nozzle I'm using is 5 only, not very big nozzle. So as you can see here, I don't care about the side components because I just have to save the main chip, not the side components because I told you already this board is, as you see, is cracked. I don't have to use the same board, so I just have to transplant a new board. So even I lose some components on the sides, I don't matter. So we will just transplant a new board. And if you like my videos, please like and subscribe my channel. I want to upload more good content for you guys. This is my first video with voiceover. I'm speaking live. I know it's not live speaking, I'm just recording my voice while I'm editing the video. But I will try to more upgrade my content and the tools so that my video looks more professional. I'm sorry if you see the quality is not much good as other YouTubers. I've just started new YouTube and I'm just learning so many new things about video recording and editing. It's really not my area of perfection. Like I'm good in motherboard repairs, but I'm not good in video recording and editing. So if you feel something not right, just write me something in the comments or give me hint or tool names how to improve my video editing. So as you see, I prefer to remove the chips open nozzle and without microscope because that is the fastest method to remove chips safely and fast.
The more time I take to remove the chip, the more heat I do on the chips. It's like not good for the chip, so it's easy for me to remove the chip very fast while I'm not using a microscope. As you can see on the side, on the small window on the up with my other camera view, the gap on the chip and nozzle is very little. Like just you have to practice your technique, like how you can control your tools. Okay, but for me, the best method is to remove any chip is without scope. Now I'm going to remove that shield. Where is the EEPROM located under the shield? So while the motherboard is hot, the shield removing will be more easy. So I can remove the shield very quickly because motherboard is still hot. See, so we remove the shield already, and there under the shield I will just take out the AP EEPROM and transplant to the new motherboard because we are in the new models after the iPhone X, from starting from iPhone XS, XS Max to all other newer models, we cannot read write the CPU EEPROM, so-called AP EEPROM. We must have to transplant that EEPROM to new motherboard, or else your phone will be stuck on always Apple or blinking error 9 was restoring. There is no solution anywhere for this until now. So AP EEPROM is a must. You have to transplant while you are doing a board swap. So remember this. Don't lose this tiny chip. If you lose it, you are fucked up. Like you can't complete the data recovery or the swapping job because your phone will not fully turn on. Now I will remove the chip with that action hot air gun. My temperature will be high, like 350 plus, because that's a small chip. I just need to remove it fast. This the chip I'm removing from the new motherboard, the CNC motherboard. There the supplier sent me with the little cut on the shield, so I don't have to remove the full shield to take off the EEPROM, just a little cut which side is EEPROM. So this is the over needed EEPROM, the one we need to transplant. I need to be careful, don't have to lose it. So I have to just take it off from this old motherboard and put it on the new motherboard instantly. So I will not reball this. I can just remove and install without reballing it. As you can see, I just remove it and now I'm installing on the new motherboard without reballing. It's just small chip, 9-pin chip. The bolts are okay. I just have to install it. I'm using the high temperature, just like so. Let that chip stay there. Then I use some flux and make it little movement when I'm hitting it. So like you can see, when the chip moves itself, like adjust to its place, so it's like installation is good. Yeah. So yeah, so successfully installed the AP prom. Now let's start with cleaning the chips one by one and reball. Then we go back to installing again all the chips one by one.
So we have that Wi-Fi chip to clean first and the memory chip. Then we will go for CPU. This is the new BJ315 NAND from iPhone 14 Pro Max. We will just clean the black glue, underfill. First, I'm doing cleaning of the NAND. I will just wick the old solder on the memory chip with some flux and wick wire. Then we see if we have to clean the black pastel glue or it's already removed with that wicking. You just have to like be careful while every time you do this wicking and cleaning. If your iron is not good or temperature is not good enough, you can damage the chip also. I'm using the JBC station to clean the glue and solder with the wick wire. My temperature from the JBC iron is 350 degrees. That is for me is perfect temperature.
Now, as you can see, we have the black glue on the side of the chip, so I'm using a blade with the Exxon hot air gun to change the to clear that leftover glue. And even the blade you're using, you have to be careful. I'm using a blade number 16 that you can find easily from AliExpress, blade number 16. I'm not using the fresh blade always. When I take a new blade, I have to prepare it for
Successful
cleaning
without
the
any
glue,
damage
like
to CPU because
making it
phone is
rough.
working.
Or if you guys want some video on how to prepare the blade, I can make also. Let me know in the comments if you guys want to see that video, how to prepare your tool for the use. Because whenever you get any new tool from China or a blade from China, it's mostly sharp, very sharp. So if you use that directly on your motherboard, you can damage it. So you have to learn how to prepare your tool as per your requirement, like how much sharpness you need. So you have to use sandpaper or rub it on the old motherboards to make it little rusty or old, so that it will be perfect for cleaning the motherboard. This is the Wi-Fi chip I'm cleaning. I'm just using the wick wire and the flux to clean. I'm not doing anything special. Like, I hope you all guys know that trick to clean the chips. There's nothing special in this. Just like be careful and gentle when you clean the CPU, because CPUs are very if you I will tell, like, CPUs are very fragile or easy to get damaged. If even a little bit sharp object you hit on the CPU, it will have a cut on the CPU or a mark that can damage so many tracks, just a tiny cut on the CPU. So we have to be careful while cleaning the CPU. You have to choose the thing you will use to clean the CPU, like a tweezer, very sharp, very thin one, or some kind of toothpick is the best option for me. Like, I didn't have toothpick near me this today, so I didn't use a toothpick. Mostly you will see me in my old videos. I was always using the toothpick to clean the CPU glue, but this time I will just use any old, or not old, like a tweezer with a very thin edge. So, but no very gentle force, not very high force, because a little bit hard force and the CPU is like gone. You have a hole on the CPU or something. So first step is I will put a lot of flux on the CPU and mix the low melt solder on the CPU balls, like tinning the CPU balls, so that I don't have any joints or the high bulbs, like the solder blobs on the CPU, that while I'm cleaning that, it will take off the card, that pads on CPU. I'm adjusting my views on the upside to left and right so you guys can see that CPU more clearly. Let me know which view you like now or before, so that next times I use that things settings like this. So I'm gonna just mix the low melt solder on the CPU balls to make all the balls equal and clear any joints or solder balls or solder blobs after removing the CPU. Yeah, just be gentle. Like, I'm not using much force. If you like feel like I'm using force on CPU, no, no. I'm just using that solder blob on the iron tip to touch every ball so that every ball is tinned. I'm not using any pressure with the iron on the CPU. Just a solder blob that I have on my iron tip. I'm using that to clean the CPU, like tinning the CPU. Just make sure like every ball is attached by the iron and every ball is tinned, because if you left any big ball or the joints while cleaning, you can touch that joint and it can come out with that CPU pad. So, and these CPU pads are sometimes very hard to recover. So you need to be very perfect if you want to recover the CPU pads on this type of CPU. Now I'm using that temperature of 180, 190. That's because of the sunlight from my back. You guys can't see the temperature showing on my action gun very nicely. I'm using the 180 degrees temperature and just slowly, slowly trying to remove the glue. Just I remembering you I want you to remember this. Be gentle. Very nicely you have to clean the CPU glue. If you use much force, even a little bit force, you can rip off the pads or make any cut on the CPU. So be careful and gentle while you clean the CPU glue. Because CPU get damaged, you lost everything you started like everything. So be careful. CPU is very fragile, so be nicely. I'm using the tweezer tip very slowly, slowly to clean the glue. As you can see my hands and the tweezer tip is very sharp. I'm just using it slowly, slowly to clean the glue slowly, slowly so that there will be no damage to CPU. So go slow, easy, don't use much force. All glue, this glue is not much hard to clean. Problem is like when you have the full CPU with the full glue. That is a different style. Like I have old video how to clean CPU. Like at that time I use life liquid. I dip the CPU there for 10-15 minutes and clean it with the brush. That is a good method also. That is the safest method. But this CPU doesn't have much glue, so I didn't use that life method. I have that life liquid to clean the CPU glue. I just using a tweezer now because the glue is not much. Just be sure, just nicely and gently clean the CPU. Not much force, else you can get ripped pads on the CPU or any mark on the CPU that can be like crucial track or something. So be nice, lowest temperature, gently clean the CPU, not much force. Else, I don't want to lose pads or damage the CPU. I see like whole glue is clean, so let's check after brush if we still have some glue left. We clean that also again a little bit if we still have the glue left. But most of the glue I know I take out, so there will be not much glue. Only a little bit glue, so we can just use it with a little bit again and clear up the mess. That's not a big deal. After cleaning the black glue from CPU, I'm just tinning the whole balls again. So if there is any big ball or like oxidized ball, it can be all equal. Like I don't use weak wire on the type of CPU. Like I feel like it's not safe to use weak wire on this CPU. I just use tinning and directly revolve. So no, I don't like the way to use weak wire on this CPU. These are very fragile, so it can easily get damaged or something. So I don't want to use that fragile, that weak wire on the CPU. I will just directly reball it after cleaning and tinning. So let's check if we have any damaged balls or nothing on CPU. I guess we don't have any. We will just reball the CPU, Wi-Fi, and memory chip now, and then install it our new motherboard. CPU seems nice and clean. I don't see any damage pads anywhere. So I'm sure 100% our board will be working because CPU is good. I will use that moist stencil for like most important chips in one set. Like it have CPU, Wi-Fi, memory chip in just one stencil. One time I will just do a filling that. After that we will just reball all at once. So, but there are some disadvantage of the stencil is also like reballing all at once. Sometimes the balls came from one to other chip. Sometimes like while you are reballing, the one ball comes out from one chip and goes to and join with the other chip. So that things are sometimes bad, but overall I like that three in one chipset. So easy for me. Just do filling one time and then reball all the chips once. So as you can see, I align the stencil on the chips. Now you start putting the paste. I'm using that alpha paste 183 degrees to reball CPU, Wi-Fi and NAND. Just make sure to fill up every hole on the stencil so then nothing is left without PPD. Just filling it up nicely. Yeah. Checking every ball have that paste on it so that I have every ball formed well. Then after that I will use a temperature to reball is 280 degrees. That's the best temperature, safe for the stencil and not overheat the chips. So once you fill the paste, let's just use the hot air gun and start making reballing. So I will use a 280 degrees temperature. First I will heat that Wi-Fi chip, then the memory chip, then at the last I will go for the CPU. Mm, okay, okay, slowly, slowly, not be in hurry, easy. Don't use like some people I see reballing with the temperature of 350, 400. That I don't like. It's like the steel stencil we have. If you use too much heat, it will like lose the shape of stencil, like deforms shape of the stencil. So I use less temperature. It's more safe for the stencil and the chip also. So now is the main chip, the CPU. Oh, chip. See the ball from that empty space comes to the CPU. It's okay. I can fix it later. First, I have to just reball all the CPU. Then I will fix this problem with that balls coming to CPU. No problem with that. You just have to know how to do it nicely. So many balls coming from the center. That as you see the place between the CPU and LAN chip, from there maybe some paste stuck there, and when I'm hitting it, making balls. So that's the only reason. The temperature 280 degrees is very best, so always try to practice your temperature, which is best for CPU reball or the chips reball without damage any chip or stencil. So as you see, we have reballing done. Now we have to fix that like big balls on the CPU. So for that I will use a blade number 23, the surgical blade, and just like use slightly on a whole the chip, all the extra solder or the balls it's coming out from the stencil, it will like make them no same size. So I just use that blade, like cutting the balls a little bit with a surgical blade. Now after cut, I will just preheat the chips again a little bit so that all will be formed correctly. Like our ball should be equal, if there's a big ball and small ball that can get short circuit under the CPU, so we have to be careful and check nicely. No ball is like big or small size. So as you can see, all the chips are reboard nicely, and let's just preheat once more time. Then we start installing the chips one by one. Then we will test the motherboard. Hope all will be fine and working. Let's see. CPU looks very nice. Yeah, all boards seems equal. I don't see any big board or something like that. First, when I'm going to install the chips, I'm installing that Wi-Fi or LAN chip first, and then I check the booting after installing chips. Then I go for the CPU because I don't want to like install all the chips and then test. Then I don't know which is a problem, like which chip have problem, which chip I didn't install correctly. So better is to test the booting after the chip you install one by one, so that you will know like, oh, before this chip the booting was good and now after this chip the booting is bad, so you know the exact culprit. Like, so better for me is install the chips one by one, then test the booting, so that you know every step by step you are doing correct. So after cleaning the flux from the chips, all the chips are ready to install. I'm just like want to be clear the CPU mostly, like from any dirt or anything on the CPU that can make problem later. As you can see, CPU looks very clean and nice. These tiny little black things I want to take out. No problem. Everything else is fine, nothing bad. So only the black little things left in the center of the bowls. I want to clean them. That's all. I'm using the brush also. It's like, from China you have to buy that special, they call it like CPU brush or like horsehair brush. Yeah, I remember it correctly. They call it horsehair brush. It's like very nicely to clean. It's very gentle on the CPU. Even I pressing it so hard on the CPU, there will be no damage on CPU. The brush is very soft. That brush I use specially only for CPU. That brush on my right side, that silver color brush, that's the brush. Like they call it horsehair brush. Let's check the CPU under the microscope. All ball seems fine. Every single ball is nice, so we don't have to worry about that misalignment of CPU. So let's get started installing by the chips one by one. Okay, yes, nice. I will start installing that NAND chip first. That gun I will use is a quick 861 Pro. That sorry, this time there is no camera on that hot air gun. The temperature I will use to install the chips is 370 degrees with the airflow set at 70. First I will install the NAND chip slowly, then after that Wi-Fi chip, and then we go for the CPU. So just patiently, like easily relaxing. Don't be in a hurry. Just make a circle movement with the hot air gun on the NAND chip or every chip you're installing, so that every part of the chip is heating equally, and you can see the chip moving on his own. So that means the chip is installed well. Until that you don't see that bubbles coming from the chip or the flux is melting and the chip is moving itself, that means that chip is not installed well. So when you feel that the chip is moving itself and the bubbles from the chip coming out, it means that chip is installed and it's moved to its fixed place. So you don't have to worry about that chip alignment. Like you just have to put it on the right place, then heat it. It will automatically adjust to its place when the balls melt. So it will catch the balls down and it will be on the place. As you can see, I'm just testing with the tweezer if the chip is like kind of moving, so that I know that okay, chip is, oh yeah. So I see the chip moving, so means that okay, chip is installed well. Now I will use the small fan to cool the motherboard a little bit down the temperature, so that I can test it on a DC supply, like what is the booting now. You know, the good booting was without the chip is 0.019. With the NAND, I think will be little bit difference or change will be like 0.02021 or 0.019 will be same. So just I don't wanna make sure there's no short, like not going to 0.100 or 200 or 1000 amperes. So better is to take step by step when doing the board swap. Like one chip installed, you check the booting. Okay, so you know, okay, the work is done nicely, there's no short. So like I'm doing now. After installing the hard disk, I will check the booting. Okay, it's same 0.019 milliamps. So it was same as before. So means we didn't have any problem with the motherboard. Motherboard is fine. Now let's just install the Wi-Fi chip now. Then again we will test the booting. If booting is okay, then we go for the CPU. I'm using the Flux. Some people use the Rosin method to install the chips, but I just use Flux. I don't use Rosin to install the chips. Just place it on the place, then just heat it. You will just make the circular movement with the hot air gun. My temperature is 370 degrees on the Quick 861 Pro and the air blower set to 70 to install the chips. And the nozzle I'm using is 8 nozzle. That's the same nozzle I will use for CPU also. Waiting, circular movement. Don't stop the gun until you see bubbles and the chip moving itself. When you have to touch the chip with the tweezer, that time you can stop your gun on one place. But before that, do not. If you hit too much on one area, it can like go the heat can spread to the other side of the board like back side you can see like we have the Wi-Fi that power chip on the back side of the motherboard, so that can get be like solder small balls coming out from that chip if you overheat the board, and like maybe you have to rebuild the power chip also if you just continuously hitting one side of the motherboard. So always when installing the chip you have to move the circular movement. So now let's test the motherboard booting current again after installing the Wi-Fi chip. As you can see right side down on my power supply set to 4.4 volts. Let's connect that lead to the motherboard. Then we test the current. Let's see how much is it now. Okay, so 0.019. Okay, we are good to go for CPU. The booting is perfect. Same booting before Wi-Fi and memory chip, same booting after memory chip and Wi-Fi. So we are now ready to install the CPU. And same temperature we use for the CPU also is 370 degrees of temperature and 70 degrees air. But before that, I have to change that board ID register. Like I have the 14 Pro Max, but the motherboard I have now prepared is 14 Pro. But there is a just little difference is one register. Like this register is 1 mega ohms, and I have to install that 49 ohms register only from the other motherboard. So be careful. Like you will see when I'm installing that register from the old motherboard, it's like I miss it from my tweezer. So there, it takes me some time to find the register, and then I continue installing the registers on the chip. So be careful. It's just if you don't have the same motherboard, then it is necessary. Else, if you have the same motherboard 14 Pro Max, you don't have to do it. I'm just doing it like to convert the 14 Pro to 14 Pro Max. That's all. I lost the register while ago while I was going to install it. So finally, I found the 49 ohm register from iPhone access motherboard near the memory chip on the upside of the donor board. So I get the 49.9 ohms resistor from there, and now I'm installing that on this to make it the convert the 14 Pro motherboard to 14 Pro Max motherboard. So that's the only one resistance difference. Its resistance number is R2405. It's like you count from down is number 4 resistance. So that you can convert the 14 Pro to Pro Max and Pro Max to 14 Pro motherboard, just change of one resistance. So I'm just spreading some flags for the CPU. Then we just put the CPU and start the same movement circulation. I'm just heating the flux and the board a little bit so that extra flux bubble will like spread out, because sometimes the CPU will get floating if you have so much flux on the down. So just make sure the flux is not too much that will make the CPU like floating, so it can move from its position. Let's just align the CPU, and then we start heating the motherboard slowly with the temperature 370 and 70 the air. Quick 861 Pro, that's the gun I'm using to install all the chips. Start heating the chip slowly circulating. Just be patient, like Don't be in too hurry to install CPU. The fastest way for me will be installing CPU is without microscope. But to show you guys under the microscope, I have to do it under the microscope. Else I'm doing the CPU installation without the microscope. That is more fast than under the microscope, because you know when you are heating under the microscope your gun is not straight on the area where you want to heat. It's like the heat is spreading on the right side of the motherboard, like which direction is your air going out. So that takes a little bit more time when installing. So just be patient and wait for the chip to move itself. I just use little bit more flux because I see it's like the flux is not enough for the chip to move. So as of me, the time is enough now. The chip should be moving itself because as of my experience, the CPU installation takes maybe maximum 1 minute only. So if you're like taking more long time on installing, that means something wrong is with the temperature, or the board is not getting heat properly, or the heat is not equal spreading on the board. Because even you heat on the one side, it will not going to work like correctly. So heat the board evenly every corner. Like that's why I'm telling the movement circulation, like move round the chip, so that's getting heats equally from all the corners. When it heats up, the flux will come out from the sides and you see some bubbles. That means the chip is installing now. As I see now, the chip start to move itself, so means the chip installation is going on. And just need to verify, just need to touch little bit with my tweezer to verify, okay, the CPU is installed. Now we will just cool down the motherboard a little bit, then we test it with the housing or with the display, sorry. Okay, so let's see if we are successful. Most probably, because I don't think any problem in installing or any missing pairs or anything. Booting was fine before CPU, so we just install the CPU. The one advice to my fellow technicians and for you guys was, main step in board swap is the removing and cleaning of CPU. Installing is just like other normal chip, like you install audio chip or that any other chip. So main step is how you remove the chip safely and how you clean the chip. Don't overheat, don't be in hurry that you can damage the CPU while lifting. So if you lift it correctly and clean it well, there will be no problem while installing the CPU. So let's check how's the board boots and what is the current now. Okay, here we go. One, two, three. And boom. Yeah, okay. Yeah, the booting starts from 0.8088 milliamps, goes up to 153, and wait there some time. And we have like turning on motherboard. Okay, let's verify it with the display. Old board have problem after cracking is no touch, so we will use the same display that comes with the device to verify, because we already verified that the display is fine, so it was only the problem with the motherboard crack. Okay, so let's verify. Mm-hmm. Turn on and we see the Apple logo. Okay, one, two, three, here we go. And boom, we had the Apple logo. Yeah, so we are successful now. That's all, guys. We repaired the cracked motherboard. Thanks for watching. Please subscribe, like my video, and let me know any problems or whatever you don't like in my video, like what to change, any recommendations. I will look into that and help that, like your views and comments help me to improve my videos. Thanks for watching. Bye bye. Have a nice day. See